two ways to check it. So we are first going to go over the ATP part. So one is that we check the time taken for the appearance. So rate of appearance. That, I'm sorry, how do you spell it? I'm terrible with spelling. Yeah, so rate of appearance of something. It could be bubbles coming out. It could be precipitate coming out. It could be anything that you see once a reaction happens. That is one way of checking the rate. The other method of checking the rate is rate of disappearance. So it could be the color goes away. So blue color of copper sulfate goes to colorless. That is one option. What appears? Products. What disappears? Reactants. So in any reaction that you do or in any method that you mention, you have to see what is going to appear and what is going to disappear and which one you're going to pick. So no matter what the reaction, when you're designing how to find the rate of reaction, you look at what appears or what disappears. So I'll give you a simple example. I have CaCO3, which is a solid that changes to calcium oxide, which is a solid, plus CO2, which is a gas. Now, first thing, will any of these be colorful or will they be white? Calcium carbonate, do you think it will be colorful or white?
White.
White. Why?
Because it's carbon.
Carbon is black.
And carbon dioxide smoke is white.
No, I'm not talking about this one. I'm talking about this one, calcium carbonate. This is white powder. Why is that? Why is it white? Why is it not blue or red? The answer is it does not have transition metal. Transition metals have colorful compounds. This one doesn't have transition metal, so it will be white. This one also doesn't have transition metal, so it will also be white. So now look at the reactant. Is this likely to disappear in this reaction? Do you see the white solid disappearing? I mean, imagine you have white solid, you heat it, and you get another white solid. Will you be able to physically see the white solid go and change into something? No, we won't. So that's why this method won't work for us. So if we want to look at the rate of this reaction, we have to look at the rate of appearance, not disappearance. So now let's see, will any of this appear? So this is white solid coming from white solid. We won't see anything. But this is a gas. Will we see it? How does a gas appear? There's bubbles, there's smoke, right? So that clearly tells me that gas is going to come out. So for this method, I will pick something that measures the rate of appearance. So how do you measure gas? You can measure its volume. So I can find rate of reaction where I have time on x-axis and volume of gas on y-axis. And initially, I know this is not going to appear. Like whenever something appears, it appears from nothing, right? So initially, it's going to be 0. It's going to start here. And slowly it's going to increase until it becomes constant. It becomes a constant value. And that is a pattern you will see. Every time something appears, it appears in this fashion. It can be like this. It can be like this, but it always starts from 0 and goes somewhere because there is a rate of appearance that you're looking at. So appearance always starts from 0 and ends. So in any reaction, just judge whether you have something appearing or not. Now, let me give you another example.